All right, let's go ahead and get started. Notes. Go ahead and put your name on them. Today is August 31st, last day in August. We have a 3-day weekend coming up, so that's nice. 8-31, practice assignment. You guys have 1.5 practice, and then we're going to have a Module 1 review that we'll get into tomorrow. Okay. Below is a standard, so you guys can read through that. So again, today we are writing expressions. Key vocab to the left here says expressions can be written using numbers and variables. This bigger. Expressions can be written using numbers and variables, or they can be described using words. When given an expression in words, it is important to be able to translate the words into algebraic terms. And then again, there's our expression represents quantity. It can be evaluated but not solved. So here is your key operators for today. So if you add, the word problem is going to say added to plus sum more than, subtraction, keyword subtracted from, minus, difference, less than, take away, taken from, decrease by, multiplication, times, multiplied by, product of, groups of, twice, and then division, divided by, divided into, quotient of, ratio of. Okay, so your keywords for today's lesson. All right, example 1. So given these word problems, we want to write an expression. Letter A says the quantity 9 more than a number. So a couple different things are going on here. Make this bigger. The first word is quantity. Quantity means you have parentheses. So the quantity 9 more than a number. I'm going to put parentheses around that. That's what that word means. So the quantity of 9 more than a number, we're going to call this number n. Okay? 9 more means addition. So all we have here is the quantity of 9 plus n. Or by commutative property, I can say this can be the quantity n plus 9. Letter B says the difference between 3 times a number and 21. When you have subtraction, so difference here is subtraction, it does matter what order you go in. Okay, difference is subtraction, because don't write this down, but 5 minus 2 is different than 2 minus 5, right? 5 minus 2 is 3, 2 minus 5 is negative 3. Okay, so it does matter what order when you have difference that you're putting your expression. So the difference between 3 times a number and 21. So 3 times a number is going to go first. This is going to be first. And we're going to call the number n. And then 21 is going to be your second term here. So the difference between 3 times a number, so 3n and 21. So 3n minus 21. Letter C, the product of 4 and the sum of 7 in a number. So product here we have multiplication. Product is multiplication. So product of 4 and the sum of 7 in the number. So keyword here is and. You're multiplying 4 by the sum of 7 and a number. Okay. So I have 4 times the sum of 7 plus n. What do I need around 7 plus n? Eli? parentheses. So we are multiplying 4 by this quantity here. Okay. Last one, letter D. Says the quotient of 5 and the quantity 3 more than a number. So quotient means, again, division. So the quotient of 5, I'm going to start with 5. I'm dividing 5 by 3 more, that's my plus sign, than a number. So I'm dividing 5 by 3 plus n. Or you guys can write this like 5 divided by the quantity 3 plus n. The fraction bar just means division. Okay. Division, it does matter what order you go in. For example, don't write this down, just watch. If I did 10 divided by 5, that equals 2. 5 divided by 10 is 1/2 or 0.5. Okay. So it does matter what order you are dividing these numbers in. Multiplication, it does not matter. That's because of the commutative property. Okay, when you guys have that down, go ahead and flip your papers over. Seminole Connect, if you guys have any questions, you can just type them in the chat box. All right, example 2 says understanding order with difference expressions. Identify the correct expression and explain why the other expression is incorrect. So letter A says Tommy has $4 less than Eric, who has $15. Tommy wrote 2 expressions to represent the amount of money he has, but is not sure which is correct. So he has $4 less than Eric, who has $15. Take a moment, circle which expression you think is correct. $4 less than Eric. Good. Good, you guys. It is the second expression. Who has $15? So expression 2 is the correct expression here. If we were to solve them, if you were confused, that would help to make sense of the problem. If he had $4 less than Eric, who had 15, this equals negative 11. Here, this equals positive 11. So positive $11 makes more sense than negative $11 here. Okay. So $4 less than, that comes second, Eric, who had $15. Good. Letter B, Emily's test grade is 3 points less than Sasha's test grade. Let Sasha's grade be represented by X. Identify the correct expression for Emily's grade and explain why the other expression is incorrect. So same as the one above, 3 points less than Sasha's test grade. So this comes second in the equation. Okay, Sasha's grade is represented by X. So here, expression 1 is the correct expression. And then explain why the other expression is incorrect. Just go ahead and write 3 points minus, that's what this says, 3 points minus Sasha's grade. Does not make sense. Okay. So if her grade is X, we are subtracting 3 from X. Last one, example 3. Letter A says last month, Ellie volunteered 24 hours at her town animal shelter. In the 2 weeks to come, she plans to volunteer an additional 6 hours. You okay, Thea? Are you okay? She plans to volunteer an additional 6 hours per week at the animal shelter. Write an algebraic expression to represent the total number of hours she will have volunteered W weeks from now. Okay, so last month she volunteered 24 hours. She plans to volunteer an additional 6 per week at the animal shelter. So we're calling weeks W. Okay, so she started with $24, kind of like a slope-intercept problem. She started with 24 hours, plus she's going to volunteer an additional 6 hours per week, so 6W. You took algebra 1 before in here. Because this would be like slope-intercept, right? This would be like your y-intercept. 6 would be your slope. Right? Letter B, suppose Ellie plans to volunteer an additional 4 hours per week. Okay, so we have something plus 4 hours per week, so something plus 4W with her church. Rewrite the expression from A to reflect this new information. So here we have, she's already volunteering, 24 plus 6W. Okay. Now she wants to volunteer an additional 4 hours per week. This goes back to Thursday's lesson. To simplify this, we can combine like terms. My like terms here are my W's. So simplifying this expression, I get 24 plus 10W. All right, last one. Mario drove 220 miles on the first day of his cross-country road trip. Okay, so we started with 220. He plans to drive an additional 240 miles each day. Write an algebraic expression to represent the number of miles he drives after D days. So be careful, you guys, in your word problem. I just want to point out here that, for example, letters A and B gave you the variable that they wanted you to use. They wanted you to use W. Letter C wants you to use the variable D. So when you guys are doing this on your own, especially on a test or a quiz, make sure you're writing the variable notation that they want you to use. So here D is number of days. So he's starting with 22 miles. 10 minutes right. 220 plus an additional 240 miles per day. So times D. Okay. All right, I'm going to go ahead and pause the recording. Those are your notes for 1.5, writing expressions.